You all set, Scott?
Good evening, everybody, and welcome. Tonight's guest speaker, Nick Johnson, who's the technical support specialist of the entire country, right, Nick?
Yeah, that's right.
Benjamin Obdyke, he's going to talk about roof and wall products. Great guy. Had a great presentation when we met him up in Rhode Island, and welcome, and thanks for coming for our presentation.
Listen, all right, excellent. Well, thanks for having me. I appreciate the opportunity to get in front of everybody and go over what we do at Benjamin Obdyke and how we can help with the building envelope and the processes there. So just a brief history on myself. I've been with Benjamin Obdyke for just coming up on a year now. Prior to that, I spent 21 years in commercial masonry field working for a CMU manufacturer for 12 years and distribution sales for 9 years. So had a lot of experience and time in front of architects and sitting down and going over designs and details and such, even if it didn't pertain to necessarily the masonry. So this was an easy transition for me when I came over a year ago. And slot right in for what they were looking for from a technical vantage point here at Obdyke. With that, I'll get started. Pop. Here we go. All right. Basic things to know to be in the know. Custom presentation for you guys. Copyrighted materials. I'll fly through a lot of these slides. But at any point in time, Jim, just let me know if there's questions, and you can go from there. My contact information here at the beginning, Nick Johnson, technical support specialist, our address. You can find me at techsupport@obdyke.com through email. You can call me on the 1-800 number or simply go to our website, benjaminobdyke.com. All that information's there. So the agenda here I put together was a review of the control layers and code and where do our products fit in. We're going to talk about what we put on the wall, what we put on the roof, flashings and accessories, and what it means to be systems and what our warranties are. So when selecting products you want to get with a manufacturer that's going to provide you a level of support. We do all of these things here. We have basic written specifications, details, and we can do plan reviews. We offer systems of products that all work together, comprehensive performance-based warranties that match or exceed lifespans of other materials. We work with other product manufacturers to ensure compatibility and continuity, offer customized project-specific training virtually or on-site, such as we're doing here today virtually, and guidance on critical components of the building envelope based off our field experience, building science, and what we know about the codes. Brief history about Benjamin Obdyke. We've been a company since 1868. We really rose to fame in the early 1900s when Mr. Obdyke invented the corrugated downspout. And we did a lot of gutters and metal as it pertained to water shedding off of buildings. Then in 1987, we came out with roll vent, the first ridge vent that could be rolled up and wasn't metal or a stick product of that nature. 1991 is about the time we rolled out with Cedar Breather, another product for the roof. This is a ventilated roof underlayment, initially geared towards cedar shingles for the cedar shingle roof industry to ventilate and dry out that space to help prolong the life of the cedar roof. And then in 1998, we sold off all the metal stuff that we did, the downspouts, the gutters, and transitioned into being more about the building envelope with WRBs and rain screens and some of the products that you're going to see. Early 2000s, we innovated with the Hydra Gap, which is one of our flagship products, with the 1 millimeter spacers to provide bulk water shedding in conjunction with being a WRB. And then in this decade, we started getting sticky with everything and putting acrylic-based adhesive on the back sides of our wraps, our flashing tapes, and started to get into that air control as well as being water control. And we'll go over some of the layers. Just some history on buildings in general. Old leaky homes built prior to 1960. We want to learn from what we did right back then. There was a good deal of success from using durable materials, constant drying potential because we weren't so airtight with our buildings. So if it got wet, it was going to dry out. Indoor air quality wasn't a concern because of the high air changes per hour, because the homes and buildings were really a lot more breathable and open in a sense. Nowadays, why is it? There we go. Now, with more complex structures, more detailed buildings and assemblies and envelopes, tighter buildings, less durable materials. Like we've see wood that is sapwood or younger wood that's grown more rapidly, engineered wood products like OSB. A lot of changes in the building materials and a lot of changes in the codes and what we want in the buildings. Indoor air quality becomes a bigger concern if you're not ventilating it properly. So there's a lot of HVAC involved with this and venting and proper air changing. So you got to stay with the times and find where you fit in and follow the building science. Complex system of building materials, more integration of details and transitions. All the trades really need to work together. And in saying that, like when we're building these airtight structures and homes, anybody who's cutting or putting a hole, or plumbers, electricians, you got to all be on the same page to make sure that we're maintaining the consistency of these layers, because when they start cutting into something, it's got to be sealed off right. Otherwise, it's not going to work the way it's designed. Lack of training with these techniques creates installation failure or creates failures. And we're leaning more into building science on this. When we talk about control layers in a building, we're talking 4 control layers on all 6 sizes. So if you imagine a home that's you're constructing, these layers on the bottom underneath the foundation, the roof, all 4 walls, kind of a cube or a dice. You imagine we need to cover and make sure that our control layers are consistent across all 6 sides of the structure. I like to use the acronym WAVT, water, air, vapor, thermal. And this is in order of importance when you're talking about building envelopes, control layers. Water, we want to manage liquid water because water gets in and mold and rot and damaging the structural integrity. We can't have that. Air control layer next, being managing the pressure differences between the inside and the outside. Vapor management. So water molecules that get into the air in a gaseous kind of state need to be able to pass through certain components and dry out properly. If we trap those, I hear a lot of people say, well, won't that create vapor lock? Well, not if you do it right. Vapor lock is something you don't want to create. And then there's the thermal aspect of things, all the insulation that's going on now in the construction industry, exterior insulation boards and so forth. So we just, we're always looking to maintain the continuity when we talk about our products, where our product stops, what picks up that layer, what is on the outside, what are we protecting on the outside? Does it make sense to use a certain product in a certain condition? So these are the kinds of things in the conversations that we have with people when promoting and talking about our products. All right, so the water control layer, what goes into the water control layer? Well, we're in the water resistive barriers, WRBs, but your cladding is a water control component, foundation waterproofing, the shingles and the roof underlayment. We've got roof underlayment and roof products that we'll talk about. Pre-weatherized sheathing like zip wall, gutters and metal capping are part of that water control as well. I'm sorry, there we go. Okay. Air control. We're usually achieving air control through the sheathing or on the inside of the drywall with the joints and the drywall. But framing material, seam tape. The WRB can be used as an air control component if it's detailed and installed correctly. The plastic that goes under the concrete slab on the foundation acts as in this layer as well. And then vapor control. Different layers or different vapor ratings and permeance ratings. So sheathing and plywood, craft face insulation, roof underlayments, smart vapor barriers, as I was chatting about earlier, the drywall, the plastics that go on, All of these things are going to control either to retard the vapor from passing through, slow it down, or throttle it through, or is it just a straight up vapor barrier and it's blocking? So some of that terminology can get a little twisted, and there's different levels, classes of vapor control based on the permeance rating of products. Thermal control components, not something that we make or do, but something we need to be cognizant of and make sure that we're working in conjunction with that. We don't want to impede the process or be to the detriment of not, making the insulation layers pointless. And I'll explain a little bit more when we get into a little bit later about mitigating what the R values are on insulation. Water control layers. Here we see this little diagram. We've got our WRB, exterior insulation in the sheathing. Additionally, furring strips or battens can be used to promote rain screen and drainage. And then you've got the cladding as well as part of the water control layer. When we talk about air control, air passing through, it can be inefficient and, not good. And we're getting towards more tight homes. Vapor will diffuse through the air and carry through there. So when we talk about vapor control, air control is part of that because air is carrying vapor. So this little diagram here is just a standard wall assembly and no hole vapor diffusion over a heating season. So, cycle through a winter, and you're going to typically pass 2/3 of a pint of water through a wall. But when they ran this test and they cut a 1/2-inch hole, and a 1/2-inch hole really is indicative of the amount of space around a single gang outlet box that would be on an exterior wall. If that's not properly sealed right, you have what's equivalent to a 1/2-inch hole, and 50 pints of water can pass through in the form of vapor through that air transmission. So that's quite a difference from 2/3 of a pint with no holes to a single 1/2-inch hole passing 50 pints. That's a lot of vapor moisture being moved through the assembly. Control layers need to work together, obviously. Vapor control, that can be achieved through all of these different products. They all are going to have different permeability or permeance ratings. So you want to be mindful of that so that that we're letting it breathe. And when I hear people ask about a building needs to breathe, really now that conversation is about vapor, not so much air. We want to be airtight to be energy efficient and keeping the air changes low in the home. But that's a different struggle in managing the air control within the home. But we want to be able to have a clear path that vapor is going to diffuse through without hitting a cold barrier surface where it can recondense into water and create bad things, mold and rot and so forth. And then the thermal control layers. This is just a photo of heat bridging, the heat transferring through those blue cool areas are the insulation, but the heat that's bridging through the wood framing, the bright yellow, and then the windows being red, that's just coming right through. So this is a large reason for push for having exterior continuous insulation so that we're not losing all this heat that can come out of the home. So installation challenging, really, this is a simple, what we call a pencil test. You want to know where your layers are, where one ends and another one picks it up. If you put your pencil down and trace the building, you should be able to keep your pencil down and tracing, knowing where it hits from one material to the other, picking up that layer without picking up your pencil. And then I don't know why. I got a spinning wheel here. Bear with me.
Try hitting your escape key on your keyboard.
Oh, something just popped up and escape made it go away. What happened? Sorry, just bear with me here.
Take your time.
Locked up.
Take your time. You're just not able to switch screens?
No, PowerPoint stopped responding.
Okay. I would try closing it, stop screen sharing, and then reopening it. Maybe that'll work.
Oh,
Oh, there you go. And now hit screen share again.
no, it's not back yet.
Okay.
Okay. All right.
You got to open up. Yeah, you got to open up the
Yeah,
PowerPoint.
I'm open now. I just got to get to the slide and then.
I'm going to jump in anyways. If you're watching this as a pre-recorded event to earn credit, after you're done watching us, send us the code 103OB24. That's 103OB24. So we'll just take a little break and we should be back.
Think.
Hey, Jim,
Are we back?
Oh, there we go.
Are we back? You is
Yeah,
that
we're back. You just have to get back to your page. There you go.
All right. Woohoo! See, and I told you I'd fly through these. I'm at slide 29 out of 82. So we're moving along at a good clip here. All right.
Good.
When it comes to 2021 IRC code update, the two biggest things that we find ourselves having conversations about are the outboard insulation component, where in climate zones. And do you see my little arrow?
Yes.
All right. So climate zones 4, except the Marine 5 and Marine 4, 6 and 7 and 8 are now required to have an R value outside of the wall of 5 or more. So depending on the assembly and where you're getting those R values, you're going to have to put something out on the outside behind your cladding. And the conversation is, where do our products fit in those assemblies? And I'll get into that more when we get into the actual products. The other thing is, the other big thing is the stone veneer and stucco assemblies. Thin veneer, masonry veneer, and again, having the masonry background, I already knew it was a good idea to have a rain screen. Now the 2021 IRC codes are requiring a rain screen behind thin masonry applications, although they do have a bit of a loophole within the wording, where you can have a drainable house wrap and then a sacrificial layer of house wrap over top of that will maintain the drainage plane in there. So in certain circumstances, you can get away with that. And it also has something to do with dependent on the climate zone that you're in. All right. And now we're about to dive into the actual products of what we make and what we do. But before we get started, let's get sticky with it. As I said earlier, all of our self-adhered membranes and our flashing tape use 100% coverage of an acrylic-based adhesive. It's a really good bond, sticks to just about everything that you're going to come across on a construction site. Sealing around fastener penetrations is a key component. When installing, applying pressure is key to activating the adhesive to bond. So you guys are familiar with probably with rollers or that being the main focus, but personally, I like to use a good stiff push broom that you don't get from a mason, because the mason's brooms tend to have concrete crud on them. You don't want to damage the product that you're using the broom on, but I like a good stiff push broom or a hand broom. We also do provide these little plastic cards. People call them debit cards or credit cards, and you get a good flat line of pressure when you apply by hand. So getting into our products, what do we put on the wall? We have WRBs and we have rain screens. In our WRB lineup, we have a flat wrap. It's a basic house wrap. Hydro Gap is like I said, one of our flagship products. It has a millimeter spacers on it to allow for, it's a drainable house wrap, allow for bulk water shedding. We have a self-adhered version of that you will stick onto the sheathing. And then our InvisiWrap product line is a high UV rated, so it can be exposed for up to a year before the cladding goes on, or it can be used in an open joint rain screen application. So if you're seeing open joint rain screens, it's all about like, well, can the space behind there be protected for prolonged periods of time? The limited amount, and I'll get into that when I hit that actual product in the slide a little more. Rain screen products, we have a pair, our Slicker line, that's a 3D entangled matrix, creates a 1/4 inch air cavity to promote drainage and drying. And then a batten UV, which is similar to a furring strip. It's a non-structural, non-compressible 3/8 of an inch, basically a big shim, if you ask me, but it keeps the cladding off the wall and off of the WRB, and creates the air gap requisite to promote airflow to dry out and be a rain screen all on its own. So I get a lot of talk about people when they talk about rain screens, they think it's a rain screen is a product. A rain screen really isn't a product. A rain screen can actually be the lack of a product. It's the space that you create between your structure and the cladding that allows for air to flow. And there's a couple different variants of what a rain screen is and how it works, and we'll get into that a little bit more here in the upcoming slides. So a WRB, often referred to as a house wrap, it's your primary, well, technically the cladding is your primary water resistance layer. As much water as your cladding can prevent from getting in, great, but water is gonna get past the cladding. This is the next line of defense, is your WRB or your house wrap. The history of WRBs. University of Minnesota did a study on air leakage through walls back in the 1930s and found building paper to be more accepted as a weather barrier. 1970s we had an oil embargo, and then the introduction of first house wraps to increase air resistance. Because at the time, up until then, a lot of these wraps were petroleum impregnated, tar paper. So when that kind of wasn't as readily available, other technologies had to develop to fill that void. Weather resistive sheeting paper was first introduced into the IRC in 2003. So prior to 2003, it wasn't even mandatory to have a house wrap on a building, on a home. 2 layers of WRB was suitable for behind stucco and veneer until 2009. And that's when we started to see a lot of mold issues because of heat-driven, inward-driven vapor. Like the cladding, the stucco would get wet, and then the sun would heat it up and drive the vapor in, and it would get through these WRB or these WRB layers and start to get back behind there and mold and mildew and bad things and rot and so forth. Drainable house wraps became a distinct WRB category in the 2010s. And then, like I said, the rain screen gap and continuous insulation became mandatory in the 2021 IRC code. When it comes to WRBs, manufacturing technology, you've got woven versus non-woven. A woven WRB is cheap, and it's just basically like basket weaving strands together. It's kind of pretty open, and it's got poor water resistance. Whereas a woven is, a non-woven is created by heating bonding strands of plastic to create a uniform material that has great strength and flexibility. So woven is going to be a better product than a non-woven product. Microporous is all in the way that plastic is made, whereas microperforated is a bunch of tiny little pinholes that get put into it to allow for that vapor transfusion to pass through. Microporous is going to be better because microperforation, that can go both ways, and you can get inward driven vapor, which is not good. Coated versus non-coated, that all kind of depends on the technology. I will tell you that our UV product our UV Invisalign product is coated, but that has more to do with the UV resistance than it does the water holdout, although the water holdout is part of the coating as well. So you have to be careful, and it's good to know what creates your water holdout with the product that you're using. Is it coated? Because if it's coated and you see guys on a job site banging ladders into stuff or damaging, scraping the house wrap, it could be detrimental to the functionality and lifespan of the ability of that house wrap to hold water out. Now, rain screen, as I said before, rain screen isn't necessarily a material, but can actually, in my opinion, I view it as a lack of material. You're creating this airspace to allow for air to travel and dry out. And that gap also creates drainage in conjunction with gravity. So if you don't have anything for water to cling on to because you've got that open space, it's going to drop, because that's what Newton tells me. So this air cavity, when we talk about rain screens, it's either ventilated or vented. Ventilated is the better of the two options, in my opinion, because that promotes the air. Ventilated has equal opening airspace at the top of the wall assembly and the bottom, and you have a chimney effect of warm air rising up the backside of the cladding, promoting drying out. Vented would be if that top of the wall is closed and the bottom is open, it's just vented. Some air is going to blow up in there based on just the natural flow of air gusts and so forth. And it is a great way to drain that cavity, but you're not getting the full promotion of airflow per se, as you see like in this little video that's playing.
Nick, just a quick question as a mason, and I think everybody here has seen it once, twice, 100 times. We see weep holes on brick, walls, exterior walls, whether it's, it's an older structure, new structure, it's just a veneer brick. We see a lot of buildings without them. Is that a problem? I mean, you got these or is it because the houses breathe more? What's your thoughts on that? A lot of these newer, you see the weep holes along the bottom of the brick. Good, bad.
It's funny that you say that, because for me, in my experience of 20 plus years in the commercial masonry world, that I dealt with some thin veneers and I know how to handle those and promoting rain screens, and I grasped that concept. But from a full bed standpoint, it was always a minimum inch cavity, and that was rare. It was usually a 2-inch air cavity behind that brick veneer. And ultimately, with that much space, it wasn't so much a concern about the airflow to dry out, but it was the space created to allow any moisture that got behind the brick to drain. So those weep holes or cell vents, I like the cell vents personally, because they get a little bigger. They're easier to hide. They're generally about the same height as a course of brick, and you substitute those in at the head joints every 2 or 3 feet along the bottom course. But they are a little bit more prone to get clogged up if there's debris that somehow is in the back of that wall. But then there are other products on the market, because you'll get mortar drippings when you're laying the full bed brick that get behind and into that cavity. But there's products out there that utilize similar 3D entangled matrix processes to create like mortar break, mortar net. Those are a couple of them. And it's just like a drainage bed kind of a material that sits at the bottom of that cavity that catches the mortar droppings and keeps them from clogging up those weep holes. I believe the weep holes, however you do it, however you weep that out, is mandatory. It is I think it's a code that it's done. A lot of times I've seen them just get overlooked, or not enough attention is paid, and they'll be put in the brick wall, and then they come in and do the concrete and they cover them up, and now they're covered. If you don't give water that gets back there a place to drain out to, you'll get efflorescence, which is that white salty looking layer that comes out on brick. That's water passing through the brick and bringing the minerals that are like contained within, and like dissolves them and brings them out to the face. It's not too much of it, I think, is detrimental. But for the most part, it's more of an aesthetic thing. But I see efflorescence all the time on new construction, because they're not giving water a way to get out of the assembly when it gets trapped behind the masonry.
Can you add them once if they're not put in or they're covered up? I mean,
can you add? Yeah, you could. Yeah, you could. You could drill out and slide, you could drill out and slide a weep hole into places, but you're doing it blind. You don't know what's behind that brick unless the wall is still open that you can see down behind it. But essentially, if the building is done and it's like, oh no, this didn't happen, well, let's just go throw some in. You could and feel better about it, but at the end of the day, like, you're doing it blind, and you're really not sure if it's going to be effective if you're getting back there, and without the use of, like, I guess, cameras or whatever. Like, you drill a hole and then shove a camera in there, you could scope it out. But yeah, it's plausible to do after the fact.
Thank you.
Hope that was helpful. Drainage and drawing, part of the solution is to create a gap. So again, that rain screen creates a really big gap. What we see in drainable house wraps is a smaller gap that provides a capillary break, so we don't have water bridging. And it gives it, a space for gravity to do its thing and drain down. Another important component is like a kick out flashing or drip edge. You're going to see these more often on changes in wall heights. But again, from a residential standpoint, I don't see a whole lot of these going on at floor breaks or anything. I used to see it all the time with like commercial work. You would have every floor would have a kick out flashing, but you want to give, again, this just leads to giving moisture a path to get out. We don't want it trapped behind there and building up hydrostatic pressure and then damaging the cladding, or even worse, somehow finding its way into the actual structure. How do we create gaps? Traditional method of furring strips or brick veneer, as we were just talking about, full bed brick veneer. You use brick ties and give yourself a 1 or 2 inch gap off of the wall, and you've got that gap. Newer technologies, we've got manufactured rain screens. So when we talk about rain screen as a product, manufactured rain screens like the slicker line that we have is a 3D entangled matrix. Drainable house wraps like our Hydro Gap here in the picture. Those are key ways to promote getting the water out and draining. Draining versus drying. There's studies were done, and it was determined that a millimeter of that space, which is why our spacers on the Hydro Gap are a millimeter, is enough of a capillary break that water doesn't just sit wedged between the finished cladding and the house wrap. It'll drain down that plane. When you want drying out, you're going to need to get a little thicker, minimum of 6 millimeters, which is a 1/4 inch. That's what rain screen products like this are in the market. I was recently at a RAINA symposium, and RAINA is the Rain Screen Association in North America, and actually learned a few things from them, and I'll speak to the insulation stuff later. But with the rain screen, in order for the physics of the airflow and chimney effect to take place, you need a minimum of 4.5 millimeters. But products are made at 6 millimeters. Why is that? When you slap your cladding on, the concern of over driving or compressing that rain screen becomes evident. If you're at 4.5 millimeters and you over compress, and now you're say 3.5 millimeters, you may not get that chimney effect, that proper drying out to take place. So what we see is a little bit of a cushion to accommodate the potential for over compressing the cladding over top. So why use rain screens? Ventilation drying versus vented drying. I spoke to that already. This promotes the airflow, and the drying capacity is pretty high with that amount of space. So showing here this stat, the drying capacity of 1.2 gallons per day will dry out from that airflow. And that's spreading the water over the entire wall assembly. Rain screen walls dry 3 times faster than a wall without an airspace. What types of claddings do we need a rain screen for? Composite woods, natural woods, thin masonry veneers, fiber cements products, and then full bed brick. We want to have that rain screen behind there. These are all what we call water absorptive cladding materials. We don't want water sitting with hydrostatic pressure on the backside. It's bad enough that this is the front line of defense for wetting events on the outside. We want that to shed down. It's going to absorb water from the outside. We don't want it absorbing water from the backside. Open joint rain screens is another. It's a rain screen, and then the joints are open between the cladding materials. So it's like inviting water and air and UV rays into the assembly. So it's a really good way to stay dry. There's a lot of airflow going on when it's just open like this. So it's a really good way to stay dry. It's just a matter of selecting and using the right products that are going to withstand the UV and water holdout properties that we're looking for. So now back to my list of our products, and we'll start to go through these. First, our WRBs. We've got our flat wrap, house wrap. From a vapor permeance standpoint, we got 16 perms. When we're talking about vapor open, vapor closed, vapor barrier, vapor throttle, anything less than 0.1 is considered vapor closed. So if your perm anything less than 1 is vapor closed. Anything from 1 to 3 is a vapor retarder. It slows it down. 3 and above is vapor open. We like to look at a sweet spot of vapor transmission being in the 10 to 20 range. Some products that are out there on the market have a vapor perm rating close to 60. The problem with being too vapor open is it will allow for inward driven vapor. So your cladding in the outside is wet, and then the sun beats down and heats it up and pushes that vapor into the building. And if the house wrap is too open, you can drive vapor back through it instead of letting it pass out. We have two different sizes, widths of rolls of the flat wrap. We've got a 5-foot roll, which is the most common, and then a 9-foot roll for a larger scale. Then, 9 foot being pretty much an entire story length. You can just wrap the house. UV exposure is a standard 120 days, about 4 months. It's a polypropylene trilaminate product. It is non-woven. So we've got good resistance from damage and surfactants. That's a surfactant is any minerals or like dirt that can be absorbed back in. So we don't have to worry about surfactants compromising our product. Good strength and wind resistance on jobs. It's an ideal WRB. This is our most basic house wrap. Next, we get into our drainable house wraps. We've got HydroGap and HydroGap SA, SA being an acronym for self-adhered. Our regular HydroGap is going to also have a 16 perm rating, 5-foot and 9-foot rolls. It's got the 1 millimeter spacers. It's a non-compressible plastic, basically spacer, compression resistance. So we're giving that capillary break for like fiber cement boards or composite woods and so forth. It's also a trilaminate substrate and also non-woven. None of our products are woven. All of our wraps are non-woven products. And the trilaminate, so we have a water holdout film in our trilaminates that's in the middle layer. So we've got 3 layers, an outside, a backside, in the middle, and we get our water holdout from the film layer that's in the middle. So these are even though we've got like the coatings, which would be like the 1 millimeter spacers, those 1 millimeter spacers are just to provide drainage. They have nothing to do with the water holdout properties of the wrap. And then the SA product, it's a little bit of a smaller roll, only one size, 4.75, because it's a little thicker because we have a release liner. It's an 80-foot long roll. All the other rolls I spoke to were 100-foot, 120-day UV rating. With all of that adhesive, our perm rating only goes down from 16 to 12, so it's not a huge thing. Our house wraps all carry a Class A fire rating as well. With the continuous acrylic adhesion, we're getting sealability around nails and fasteners in the material. The acrylic adhesive sticks to, like I said before, just about anything. OSB, CDX, concrete. Temperature range for all of our sticky products is going to be as cold as 25 degrees, and you can install them in hot temperatures that exceed, what Earth is going to throw at us anyway. So it's quite all right. Also, when we're talking about self-adhered, and I spoke to it earlier, WRB can act and be incorporated as your air control layer. The self-adhered products are great for adding as your air control layer because we're sealing to the substrate surfaces. When we're talking about mechanically attached wraps, you're going to need to tape seams and make sure that the terminations are taped and carrying that air control itself. 9 times out of 10, air control is generally done through the sheathing, taping the seams of the sheathing, and that's where we usually find the air control is either on the sheathing or actually on the interior with the drywall. But when doing a whole home evaluation, and when I talk about our self-adhering roof underlayment, you can take those products and work in conjunction and create your air control layer in the same plane as your water control as well.
So, Nick, a lot of times I'm seeing a lot of these roofers are doing ice and water shield. I just studied your thought. They're doing the whole roof. And some of them say, oh, yeah, it's fine. It's fine. And other people say that's not good because it's not allowing, the moisture in or the moisture out. What's your thought on that? Because your product allows that moisture to escape, right?
Yeah, ours does. Ours has a vapor permeance. I believe when we get to it, I think it's 12. I got a lot of numbers in my head, but it's in that same sweet area that I spoke to earlier, being between 10 and 20. Yeah, if you're trapping vapor in the roof, and honestly, like hot air rises, and hot air is what's carrying, vapor. If you have a ridge vent or you have, eaves and the air and air coming through the soffits up to the ridge vent, I mean, it's not terrible. And also, where is your insulation, and how are you achieving insulation? So I have some slides when we get to the roof product that will kind of go over what that means. But in my opinion, covering your entire roof with an ice and water shield that has a 0 vapor permeance, it wouldn't be the way I would go if I was building a new home.
Nick, I'm going to break in. I'm going to break in for 1 second. If you're watching this as a pre-recorded event, the code is 46522OB.
Okay. Let's keep it rolling here. All right, Inviswrap UV house wrap is our mechanically attached black house wrap, and then again we have an SA version of it as well for self-adhered. Again, the rolls are slightly different in their sizes. Mechanically attached versus self-adhered, I'll go over some of those details in a moment. Inviswrap is going to give you a full 12 months of direct exposure to UV. So if you know you're going to have a long time before you're getting your cladding up on the outside, this is a great product to have. Our other products only last about 4 months, which is about the industry standard for most house wraps. It's a fully blacked out. So if we're using this in conjunction with an open joint cladding, you're not seeing the house wrap through your open joints of your cladding. When I talk about mechanically attached versus self-adhered, our installation guidelines, we recommend cap fasteners for the mechanically attached. You get a better bond, better seal at that with those staples. There are certain types of claddings that if you use a manufacturer that says, no, we can't have cap fasteners, it'll create a waviness in our cladding, just call us up. We do allow for exceptions. Meeting our warranty standards for our system warranty, cap fasteners are required for the mechanically attached. But again, if we're working on a project in conjunction with the architect and the builder or what have you, we do have the leeway to make some exceptions depending on the circumstances, the location, and what all is going on with the project. So something to keep in mind. But best practice from our concern with mechanically attached cap fasteners, and with the exception of an open joint cladding, mechanically attached, I would tell you, there's no need to tape the seams. Some guys, they install house wrap all day long and they just tape the seams because that's ingrained in them. That's embedded in them. That's been the nature of how they've done it. Leaving the seams open is fine in our opinion. It's better should there be a breach and moisture gets back there. You have the opportunity to have somewhere to allow for anything. But when it's being used as an air control layer, tape the seams. If it's being used as an open joint cladding, tape the seams. The self-adhered products don't need seam tape because they stick to themselves and they stick to the wall. So there's no need for that. All right, rain screen materials. We've got our Slicker Classic, 1/4 inch, 6 millimeter thick, 3-dimensional entangled matrix product. Creates that gap between the cladding and the WRB to allow for drainage and drying. Again, it's key if you want the ventilated system, which to me would be the preferred design, to have it equal gap opening for air to come out at the top and air to come in at the bottom. Typically, I get a lot of questions, people looking, okay, what do I do at the bottom? I need like a kick out drip edge or a weep screed or something along those lines. That's not something we make. There's a lot of different varieties and options and conditions. There are companies out there like Schluter that make accessory trim pieces just for that kind of stuff. So that's generally where I direct people to when they inquire about that. Our Slicker Max has a filter fabric that goes on the outside. And this is what would be used for thin masonry applications with a scratch coat, where it blocks any of that mortar going on the scratch coat from impeding the rain screen space or blocking it up. So it protects that rain screen from like mortar intrusion. Additionally, there are certain types of claddings that I like to say have an exit wound. You fire a nail through it and it has a blowout on the backside. This filter fabric protects that from getting into the rain screen space and blocking it off. Also, it adds a bit of the Slicker Max has a higher compressive strength too. So when people ask, well, I'm worried about the compression, then go with the Slicker Max. It's got a higher compression standard. Our batten UVs, these are non-structural, the biggest hurdle that we come across. This is just to create the bump off, rigid. It is non-compressible. It is UV stable, so it works well in an open joint cladding situation. 8-foot lengths, 3/8 of an inch thick, gives the perfect amount of bump off. It's essentially like a furring strip, but with no structural capacity. You're going to line these over on the studs generally for horizontal applications. If you're doing a vertical cladding, they are notched to allow for drainage, and you could run them horizontal and have drainage. You're just not going to promote the airflow and air channel. Ideally, if you had a vertical cladding, you could run these battens diagonally, and that would still give you some level of air movement with a chimney effect in a diagonal fashion. All right, now on to the roof. We've got an underlayment, we've got a ventilation mat, and then we've got a variety of different types of ridge vents. Why do we need an underlayment? Again, like the cladding, the actual finished roof, your shingles, your cedar, your metal roof is your primary defense for the roof. The underlayment is a second layer of defense on the roof. We're going to looking to protect the deck, prevent water intrusion from wind-driven rain, protect the structure of the roofing installation, dry in the building as you're building it up. You're going to put your underlayment down and then, dry the home in. Self-adhered products, again, we're getting, sealability around nails and penetrations and fasteners. And ours is a permeable product that allows water vapor to dry to the exterior. Trapped vapor, again, now this comes back to that last question about the roofing product. Trapped vapor, we see rot here because it wasn't vented, and you can see the ice and water shield being peeled off. It's trapping that moisture in the ridge, trapping it on the roof, and it just molds and rots. Here we see vapor diffusion in action. Well, not really in action, but a nice little drawing here. Vapor impermeable roof underlayments trap the interior moisture. High humidity in the attic can cause condensation and mold. Ice and water shields used on the entire roof deck are going to trap interior water vapor at the ridge of the roof because the underlayment is vapor closed. Now, if you have an open ridge, like my home in my attic, I have an open ridge and an open ridge vent. My underlayment is, I believe they used felt paper back in the day, is what I have under my asphalt shingles. But we're promoting air through the soffits and up the joist, the roof joist to the ridge. So that's drying out and allowing vapor to escape. But what we're seeing a lot more are unventilated, closed attic conditions, and people still doing the same roofing practices that they did for eons and trapping the vapor in the structure. Traditional vented roof assembly used to cool and dry the air, the entire attic from the eave up to the ridge. So having this ventilated mat under your shingles helps promote drying out and airflow, taking the heat off of the roof. So change from vented to unvented can create trapped vapor. High vapor concentrations near the ridge. Again, vapor impermeable products will damage the sheathing and doesn't promote outward drying. So we want to prevent water from getting in and allow vapor moisture to pass through. Tricky subject. Conditioned attic space solutions. Add a cold roof to the conditioned attic space to reduce condensation risks. Add ventilation above the self-adhered vapor permeable roof underlayment and maximizing your drying potential of the whole roof assembly. SIP systems highly benefit from an airtight and vapor open underlayment. So again, when we're talking about the installation, even there's going to be cracks, and a lot of installations are vapor closed, but there'll be cracks and vapor gets into those spaces. And if you're not vapor permeable on the deck, it's going to stay up in that area and rot away. When it comes to testing, a lot of the kickback we get since we launched Vapor Dry is like when we say it meets the same standards as an ice and water shield. ASTM testings for ice and water shields are based on asphaltic rubber-based ice and water shields that are 40 mils in thickness. So we technically don't test through some of those tests in the ASTM because we aren't 40 mils thick and we're not rubber or asphalt. So the International Code Council put together a more strict line of testing standards to evaluate ice and water, and it's the AC48. Our Vapor Dry SA passes all of these tests within the AC48 code for the ICC. Additionally, the ASTM D1970 code, which centers around nail sealability, our Vapor Dry SA passes that as well. Air control transition, like I was saying before, if we're using the roof underlayment in conjunction with the wall WRB to create a whole home air control transition, we just want to make sure we detail that properly. You can see in the drawing here, the suffered roof, we create a simple air control layer. We start on the fascia and come down, and you can kind of see, right, let me get my arrow, right here, the underlayment wraps up the soffit and onto the subfascia and onto the deck. We've got our drip edge over top of that, and then we come back over with another layer of the roof underlayment to maintain that plane of the air control. Oh boy. All right. On the roof, here are our products again. So we'll run through them. Vapor Dry SA. This is the one. This is vapor permeance of 14 perms. It's also a trilaminate membrane layer like before. Outside, backside, and then our film that protects on the inside. Great walkability. A lot of people, when we're at like the JLC and the shows, we've done some projects that have been, on Instagram and so forth, and a lot of people are impressed with the walkability and how secure they feel with this product under their foot. Continuous acrylic adhesive, sealing those fastener points if you're nailing your cedar shingles or you're nailing your asphalt shingles. Awesome product to use. Cedar Breather is our ventilated roof mat that goes on top of the underlayment. And this was really developed back, like I said, in the history review in 91, we launched it as a way to promote air drying under wood shingles to prolong the life of the wood shingles. This gives a great drain plane. Again, water that wind-driven rain or water that passes through the shingles has a place to just hit and dry. There's no hydrostatic pressure building up. Vapor coming up through the from the home and exiting out isn't trapped under the roof, the finished roof. It hits into that space created by the Cedar Breather and it allows it to drain. We have a variety of ridge vent products. So depending on the need of the project, we've got, you can see from this chart, we've got different sizes and widths. So it all kind of depends on what the roofing material is and what kind of ridge you have to span with it. We have rolled form. We do have solid stick form, different material products. The key thing here I like to point out is the NFA, the net free area. So for every linear foot of the ridge vent, you get 12.5 square inches of net free area. You need to have an air source equal to that from the soffits and the gables and the eaves to come up. Otherwise, you're going to create like a reverse pressure and suck air in through the ridge. I dealt with a customer out in Nebraska. They had serious snowstorms last year. They were getting snow sucked in through their eave. They didn't have enough net free area for air source lower, and they had too much ridge vent opening, and it created a negative pressure effect and sucked snow into their home.
Nick, on the ridge vent, a lot of times when we're inspecting, we go into the attic and we see they didn't cut the wood out on the sheathing, and the roofer just put the ridge vent on to make the client happy that, oh, I have a ridge vent, but the client doesn't know they didn't cut the wood out. Is there any specification? I was always taught like it's 1.5 inches on each side of the peak.
Generally speaking, that sounds about right. But again, it also depends on what kind of ridge vent product. Like each one of these, I would defer to looking at our installation guidelines, our website, and I'll talk about our website at the end for the resources that it provides there. But for each one of these ridge vent products, it's going to be a different limitation to what that ridge needs to be, what that ridge opening needs to be. But 1.5 inches, that's kind of like a general common measurement. But you want to be mindful of what ridge vent product are you using, because if it's not wide enough and you cut it too wide or you don't cut it wide enough, like all of that, it should be taken into account. And that's really more dictated on what are you using for a ridge vent. What kind of cutback do you need to have on the ridge to properly accommodate that? Because if it's overcut, you don't get enough overlap from the vent. sometimes you need to gasket the stuff. So in other words, you wrap the underlayment over the top course of the cedar shingles to create a gasket to accommodate sealing off any irregularities in the finished surface of the roof material itself. So
now, if you have a house that did not have a ridge vent but just had soffit and gable vents, and then you stick the ridge vent on, are you supposed to cover up the gable vents? Because convection will have the air go to the outside.
Yes.
Okay.
Yes, you don't want both. Yes. Okay. I know yeah. So the gable vents, those are the ones that are on yes, they're like in the wall.
Yes.
Right.
Yeah.
So yeah, you either have one or the other. You don't want both. That has been explained to me before. It is you're not doing yourself any service of proper ventilating if you have them both. You want one or the other. There are also products out there that are like motors and fans and things you can put in your roof, and they're promoted as, drying out and blowing the air out. And people will get suckered into like, oh, I should have that on my roof. Well, you've already got a gable vent. You've already got a ridge vent. Like, you don't need a motorized fan. Now you've got to also you're going to put it in your roof and make sure you seal around it. That's one of the toughest things to seal, are like those different changes in direction on the roof. If you don't gasket them right and flash them properly, you're going to have a leak then on top of that. So yeah, you got to be mindful of that. And you don't want both. You don't want gable vents and a ridge vent. It doesn't make sense.
Thank you.
All right. Off of the roof and onto our flashing and accessories, and we're gonna wind this down right at the hour. Flashing tape. We have GP, a UV plus. We have a liquid applied flashing, and then we have a double-sided tape and hydro corners. I'll explain those as we hit them. Peel and stick flashings, adhesive options, rubberized asphalt, butyl, acrylic, which is the gold standard. Like I said, everything we do is acrylic. One of the common things I get from people, hey, I'm on a job and I have your HydroGap, but I don't have your tape. I have this butyl tape. Butyl does not stick to our product. So something from an inspection side of things, you always want to be mindful of compatibility of products. So if somebody's using all Benjamin Obdyke products, good chance you're compatible. Any manufacturer, their product lines are generally compatible, but be mindful of it, because I know some have different types of tape where they have a butyl tape and they have an acrylic tape. Which one is the right one to use with their house wrap? Keep that in mind. Specs that matter: chemical compatibility. Rubberized asphalt is not going to be compatible with flexible PVC and other sealants. Adhesion compatibility, like I was speaking to. Our wraps aren't compatible with butyl-based tapes. Installation is key. Again, I said earlier, pressure is the key when applying any adhesive, sticky product to something. When I showed you the HydroGap self-adhered, and I said I like to use a broom, that's the main reason why. If you use a roller on something that has a non-compressible spacer on it and you roll that product, you're only making pressure point contacts at those spacer points. You're not getting a full pressure applied across the entire plane of that material. So you want to make sure you're getting firm pressure, but also are you using the right thing to apply that pressure to something. Peel and stick flashing. Site conditions should be dry and conditioned environments. Storage and handling, clean surfaces, dry surfaces, the right temperature. Again, our sticky products can be applied as cold as 25 degrees and is warmer than what the earth can throw at us. Installation techniques: proper shingle overlapping, work from the bottom up, incorporate drip caps wherever possible, drips over the windows, drips over, at the bottom of the wall outlets. Just things, again, good practices, building science kind of stuff. Proper shingle overlap goes a long way. You can have a mistake and be like, oh, and you go to correct it. If you're lapping from, above down on top of something, water, think like a raindrop. We often say water hits something, it gravity takes its force and pulls it down. So we want to let that water go all the way down. Our liquid applied is an STP compound, silicone poly. It's a STP terminated polymer. It's gunnable. We have 10-ounce caulks and 20-ounce sausages, moisture cured, sticks to just about anything. It's great for that transition where you need to seal from wood framing to a concrete foundation. It's an awesome product to use. Get yourself the right wet mill thickness there with that little guide. Common installation errors, reverse flashing. You see this guy over here? We don't want flashing going up, proper shingle overlapping, as I said before. You have a reverse flash when you leave that top edge exposed. You might have it stuck down really good, but as you can see from the little video, water coming down is going to catch that lip of that surface. Again, if you have something like this because you had a repair or you had to fix something that wasn't done right the first time, our liquid applied flashing is it creates a monolithic seal and bond, and we don't have the concerns about a reverse flash incident. The compatibility, again, if you got products that aren't compatible with each other, they don't stick to each other, you're going to get a reverse flash occurrence. And we're almost done. What are the products? Hydro Flash GP. It's our white acrylic based. This is vapor closed. Options are 2.3 inch, 4 inch, 6 inch, 9 inch. Again, something I didn't specify earlier on our self-adhered wall membranes. The nice feature is the release liner on the backside is split. So you can peel off the top, set it, get it nice and pressured, and then go back and pull the release liner off the bottom half. Makes it really easy to work with. Our tapes, our 6 inch and our 9 inch also have a split release liner. So you can peel half the liner off, position the tape, apply the pressure, pull the other liner, and finish it off. Our UV plus flashing tape. This also has the 365-day UV exposure limit. This tape is vapor open at 4 perm at a 4 perm rating. This is my preferred tape when I do trainings and installations, just because I like the feel of it. It's softer. It's easier to use. I can get better pressure on it I don't know. It's just my own personal preference. Also available in those same sizes as our GP. Our liquid applied flashing that we saw that little video on, you want to get 20 to 40 wet mills in the thickness. Generally speaking, it takes about 2 to 3 hours to be tact free, and then a few more hours to be fully cured. It wet cures, so it likes moisture to help its curing process. It is also vapor open at 3 to 6 perms, depending on where you land on that thickness. I had questions where the people call and go, it's not curing, it's not curing. Relative humidity in the air, because it's moisture cured. Generally, ideal conditions, 60% or greater relative humidity. I had a call from Utah. The guy was like, it's not curing, it's not curing. His relative humidity was less than 10% for 3 weeks. You can mist it. You can, introduce water to it to help it speed up the curing process. Hydro Tape DS. This is a double-sided acrylic tape. Basically, it's acrylic with a release liner. So it comes off like a roll of tape, and then you peel the liner off. This is what I would say to use for seam taping when you got a seam tape. It hides away. You put it in between the layers. Again, it's vapor open, acrylic-based adhesive. Our Hydro Corners is a little plastic corner-shaped thing. The most vulnerable spot in a door or window opening is going to be that bottom corner. When they go to set the windows and the doors, they got to shim them. They got to get them level right. If that sill pan isn't created just right, the most vulnerable part to take on damage is going to be in that corner, and moisture will go to that corner, and then you can have problems. This little plastic doohickey here, the Hydro Corner, is a great option to protect that most vulnerable point in the window and door assemblies. If not doing that, our instruction guides are to take the tape and create a bow tie or butterfly and add a little bit, just to add some protection to that corner. Coming down the home stretch here, systems and warranties. When you combine our products into a wall or roof assembly, it constitutes as a system. So WRB and flashing plus a rain screen, our underlayment on the roof and the ventilation mat and a ridge vent. When you combine those, it creates a system. When you have a system, it bumps up the warranty coverage. So our warranties, I didn't put them in here, but generally speaking, we just revamped them at the beginning of the year. Our basic product warranty, if all you use is our house wrap, and let's say you use somebody else's tape, that'll get you a basic product warranty, 15 years that product is not going to give you any problems. You use our flashing tape right away, that makes it a system, and you're up to a 20-year warranty. You add in a rain screen, that adds another 5 years. Our warranty, our system warranties also cover labor costs as well. So it's an added benefit. Then if you really want to get nuts and use our products on the roof, our sticky products on the roof and our sticky products on the wall, you can get a 30 or 35-year warranty, whether or not you have the rain screen in there as well. So in conjunction, it's just an added point for, you know, we're comfortable when our products are all working together that they're going to last even longer for you. And we stand behind that. Lastly, I was talking earlier about an interior vapor membrane. We are launching this as soon as it gets off the water. The first order is in for the New England market. Vapor Wise, a Vapor Smart, like the field is Vapor Smart. So it's a vapor variable interior membrane. So when we're talking about when controlling the vapor on the interior side of things, with insulation in the cavities, this is a new product that we're coming to market with. It's tri-laminate again. It is reinforced mesh on the inside. It's a translucent membrane. That reinforced mesh is ideal for blown-in cavity insulation. Depending on the relative humidity inside of the house, determines the variable of the vapor openness of it. So we go from 0.14 perms to as high as 14 perms. So when it's warm and moist, it's gonna pass through. When it's cold, we're not letting any vapor pass through. It becomes a class 2 vapor retarder. Again, something new, and I didn't include the IRC talk about it, but vapor retarders and vapor barriers are outlined in the IRC codes as well. So it's something that it's so new to us. I'm still learning more and more about that. And that's
Nick,
it.
No, Nick, thank you. It was fantastic. And I know we're a little bit over. So one question I have is, and I don't want to talk about a competition. Is that similar to CertainTeed's membrane? Because that, you know, that's what they recommend. Because there's really, I didn't know there was another product there. And I put Rockwell in my walls when I just didn't do spray foam. I wanted Rockwell, but I had to use a membrane that, you know, obviously when it's warm, when it's warm, it kind of loosens up, and then when it gets cold, it tightens up. Is that similar to that product?
It is. The biggest difference between CertainTeed's membrane and what we're bringing to market is the CertainTeed membrane is almost like, because I have some that I've been playing with in our warehouse. The CertainTeed membrane is almost like, looks like poly, looks like plastic.
Looks like plastic. That's right.
Right. Yeah. It's rolled up and folded, all origami style, but it's not reinforced. You can't use CertainTeed membrane if you're doing blown-in insulation. Or you have to do a whole lot of strapping to the interior wall to hold the membrane.
So your stuff I can use with Rockwell. You can use that with Rockwell, or you can use it blown in, that product, which is not out yet. You said almost coming out.
Yeah, we're working with our distribution partner in New England. Given the demand and the constant inquiries for a product like this, we're putting our pinky toe in the pool for this. So I'm still getting accustomed to it and learning about all of the intricacies of it. I know our recommendation is, if you're not doing blown-in insulation that creates that pressure to want to pop it off the wall, our double-sided tape, we're hoping that is going to be a good component with that. You run the double-sided tape on the studs, you apply pressure when you stick the membrane on, and then you put your drywall on over it. It can be used in the ceilings and on the walls, so you can maintain that continuous continuous vapor layer.
Cool.
Thank you.
Well, thank you very much, Nick. I just got some stuff on my phone that the strikes looks like it's over, so your product should be coming in soon. So that'll be good. I will have this webinar posted on the website if anybody wants to review anything. But this was extremely informative, and I'd like to thank you for your time. It's very much appreciated.
No, I got more. If there's more questions, my kids still are at sports practice, so I got time.
I'll just ask if anybody has any questions. We'll give it another minute or two. But if not, we'll call it a day. So
write the number down, and we can always call you if we have a question. If we have to do some newer
Yeah.
Go to our go to
remodel.
our website. If you're like, oh man, I wish I would have wrote that down. Just search us. Search Hydrogap. People will struggle with our name. They call Obdyke. Obdyke. How do you pronounce it? It's Benjamin Obdyke, and then they want to know how to spell it. So if you Hydrogaps is probably a way easier to comprehend and hit on a Google search. They'll be like, oh, what that guy was talking about Hydrogap. Google Hydrogap, you'll get directed to us. But go to our website. We've got a lot of helpful videos. We've got downloadable CAD files. We've got instruction guides. We've got, again, the helpful videos, product reference pages, spec pages, property data sheets, all the typical stuff you need to provide and, get through your projects or whatever. And if you get stumped or you have something that you need some, consideration for, I've got this, one of the products that we work with, I'm drawing up, I'm brain farting here. True Exterior, their panels, they don't want cap fasteners behind them. So then that becomes a conflict of like, well, who's, now I avoid the warranty if I use cap fasteners because that's what we need for your warranty. If you use a self-adhered membrane, there's no need for cap fasteners. So that's the first direction. But if we are working with people on projects and talking through it and we can, maybe have a rep stop by and take a look or whatever, like we're willing to tweak things and make certain accommodations if we're comfortable with the situation and how things are going on. So that's something that we do it from the technical side of things.
Well, thank you very much. We'll be in contact, and I'll shoot you an email about that PowerPoint, and we'll go from there. All right. Thank you, everybody.
Thanks.
Thank you. Have a good night.
Guys. I appreciate your time.
Good night. Good night, Nick.
Good night.